Welcome to another tutorial of ProfLearn YouTube channel. This particular video, we're going to have a discussion on simultaneous equations, a topic in pure math, Unit 1. So we're going to have a detailed discussion on what you're expected to do and different questions that have been different questions that have been asked in previous and recent examinations. So we're going to see how to solve straight lines and curves. We are going to see how to find the coordinates, and also we are going to see some of the case study of sketching graphs. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. Going to the first question, we are given a straight line whose equation is k into 2x minus 1, where k is a constant, and we have a curve C whose equation is y equals to x squared plus 2x plus 11. We're supposed to find a set of values for which L does not cross or touch the curve C. Now, in this situation, if you are told that the curve does not touch or the line and the curve does not touch, something that you need to remember is the discriminant. And in that case, when they don't touch, the discriminant is less than 0. If you are told they touch at one point, it means the discriminant is equal to 0. But if you are told that the line and the curve intersect at two distinct points, then you are going to say the discriminant is greater than 0. We need now to equate the two equations here and try to see exactly what we are supposed to do. In that case, we are going to equate the first equation that we were having here, which we can call equation 1, and the second curve we can call it equation 2. So substituting 1 into 2, we are going to form now a quadratic equation. We're going to expand all the like terms together so that we can form a quadratic equation and we can be able to be in a position of identifying what is A, what is B, and exactly what is C. So in this case, we can now say we have a quadratic equation where A is 1, B is 2 minus 2k, and C is k plus 11. Now, since we say that touch do not cross or touch, then it means the discriminant is going to be less than 0. So meaning that we can now substitute into the equation and find the discriminant. And in that case, we can see exactly what we are going to get at this point. Now, we have this as our inequality, so meaning that we can even divide by 4 all through, and it's going to reduce to this. Once we have done this, we are going to solve the quadratic equation. Yeah. So solving the quadratic equation and then sketch that graph the way it looks like. So we can solve this and get the critical point. Solving the quadratic equation, we can be able to get the critical point k equals to -2 or k is equals to 5. So this is -2 and that is 5. But remember, we need the region below the x-axis because the equation that we are trying to solve is the equation less than 0. So we need the region below. Then when it's that case, for you to state the range of values for k or set of values for k, we're going to say that k is greater than -2 but less than 5. And that is the answer that we are supposed to get at this given point. So the take that you should grasp at this question is that if you are told the lines do not intersect, the lines do not touch, then it means the discriminant is less than 0. But if you told they intersect at two distinct points, it means the discriminant should be greater than 0. But we are going to see cases of such kind of questions. We need to move to the next question. Here, we are told that the figure shows a sketch of curve C with equation y equals to x squared minus 5x plus 13. We have M as the minimum point of C. The straight line passes through the origin and intersect C at the point M and N as shown on the diagram. The first part in the question A, we are supposed to find the coordinate of M. And remember, for you to find the coordinate of the turning point of the quadratic equation, what you are expected to do is to complete the square. We are going to use completing square method so that we can be able to express that equation in a way we can be able to find the coordinate of the turning point. Now we are going to say this is y equals 2. We shall group these two together, and then we shall pick x minus a half of the coefficient of x, that is a half of b, and then we say squared, then we subtract the square of 5 over 2, then plus 13. Simplifying this, we are going to get our value, our equation be reducing to plus 27 over 4, right? So in order to state the turning point or the coordinates of the turning point, we are going to say this is going to be positive 5 over 2, because if it's a negative inside bracket, you take a positive. But if it's a positive, you take a negative. That one you have to remember that. But the outside value 27 over 4 gives us the y coordinates, and we are going to take the sign the way it is, so it will be positive 27 over 4 as the coordinate that was expected for this case. We need to find the coordinate of n, and the strategy we're going to use in order to find the coordinate of n, we are going to find the equation of the line L, the straight line. But remember, this line passes through the origin, meaning that the y-intercept C is going to be 0. But we can be able to use the coordinate M that we have there to find the gradient of the straight line. So finding the gradient of this straight line, we are going to get the gradient is 27 over 10. Yeah. So the y-intercept is going to be 0. So this is going to be gradient is 27 over 10. And y, therefore, is going to be y equals to mx plus c. So it will be 27 over 10x plus 0, which is the equation of the straight line. Now, in order to work out the coordinate of n, we are going to equate the equation of the straight line and the equation of the curve, so that we can solve the quadratic equation that we are going to form. Solving the quadratic, we are going to get our x is 26 over 5, or our x equals to 5 over 2. But 5 over 2 as the value of x, we had gotten it as the coordinate of m, so that we are going to ignore this one. We shall take the value of x in the n coordinates. We are going to take it 26 over 5. So we shall use it to find the value of y by substituting into the equation of the straight line, and that is going to translate to 251 over 25 as the final answer. Then we can go ahead, write the coordinates that was expected to be given in that particular question. The next area is to state the inequalities that satisfies the region R. Of course, we were given the equations of the curves and the straight line. So this region R is defined by various inequalities. Number one is the equation of the curve less than the equation of the curve, which is y is less than x squared minus 5x plus 13, and also y is greater than 27 over 10. So those are the first two inequalities we are going to notify there. The other set of inequality is that we can see there is no values of x beyond the 0 value. So we have values of x greater than 0 but less than 5 over 2. So we need also to identify that R is satisfied by the value x is greater or equals to 0 but less than less than, strictly less than 5/2, which is 2.5. So those are the inequalities that satisfies this particular equation. Those are the inequalities that satisfies this particular equation. If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. All right, so we need to move further to the next part of the equation. In question number 3, we are given a equation of a straight line y equals to 4x plus c, where c is a constant, meet the curve y equals to x into x minus 3 at only one point. So if you are told a line and a curve are meeting exactly on one point, it means that the discriminant here is equals to 0. The discriminant is equals to 0. You are going to meet such kind of questions whereby you are told that a line and a curve meet at one point, or a line is a tangent to the curve. So in such kind of scenarios, you are going to take the discriminant is equal to 0. Now we are going to equate the equations and the equation of the straight line and the curve, so that we are able to form a quadratic equation which we are going to use to find the discriminant. And in that case, the discriminant we are going to say is equals to 0, so that we can be able to make C the subject here, and we shall say C is equals to negative 49/4 as the final answer. So C in this case is negative 49/4. Then now we can be able to move to the next question. Hence, find the coordinates of the point of intersection. So we have already gotten the equation of the straight line, and we have the equation of the curve, then meaning that we are going to solve these two simultaneously. We are going to equate or use substitution in order to solve them. Now, using substitution, we are in a position of forming an equation which we can be able to solve at this given point. And solving this, we are going to get the value of x being 7/2. And you can see now, since it's a quadratic, it has two solutions, but these are two repeated roots. That's why we were told that it meets at exactly one point. So x is 7/2. We can be able to substitute this value of x into the y part of the equation of a straight line or the equation of the curve, and then we can be able to get the value of y being 7. So we can now write the coordinates the way it was expected for us to do, and have our coordinate as such as the final answer. Now, as you know, usually questions are never tested in isolation. Questions can be set from one topic, and they're borrowing from concept of the other topic. That's why we have question number 4 here. Is a question that deals with uh, radian measure or circular measure, area of sector, perimeter of sector, but at the same time testing the concept of solving simultaneous equation. And that is exactly what we are going to work out in this next part, where we are told that a sector A or B of a circle center O has radius r and angle theta radians, given that the area of the sector is 6 centimeters square and the perimeter of the sector is 10 centimeters. We are supposed to show that 3 theta squared minus 13 theta plus 12 is 0. We are going to start by sketching and drawing the shape of the sector that we are told, and then we shall identify that we have the angle theta, we have the radius, we have the arc length, but we know that area of a sector is given by the formula that is here. And then since we were given the area of the sector as 6 centimeter square, we can be able to substitute r because we take the radius to be r, theta is theta. and then the angle is theta rather, and then now we can use the formula for arc length, which is r theta. Use it in order to work out the perimeter of the figure. So remember, arc lengths are theta, but perimeter is 2r. Perimeter is distance all round, so it's 2r plus r theta, and r theta is the arc length of the curved part, the curve of that sector. Now, once we have done this, we can be able to substitute p with 10 and then make r the subject of the formula, so that once we find what is r in terms of theta, we can go ahead and find what and work out, substitute it in the first equation, so that we can be able to form an equation in terms of theta only. So we can multiply both sides by 2 plus theta squared, so that we can form a quadratic equation. Expanding this, we are going to get 12 into. So if we open the brackets and try to simplify what we have, finally we are going to land at 3 theta squared minus 13 theta plus 12 is equals to 0. Of course, we can be able to divide by 4 all through. We are going to end up having 3 theta minus 13 theta plus 12 is equals to 0. That's exactly what you were supposed to show. The strategy was to find the equation for the area of the sector, find the equation for the perimeter, make R the subject, and then substitute for you to have an equation that has only theta. Then hence find possible values of R and theta. And in this case, we are going to solve the quadratic equation that we had formed in terms of theta. Once we have the quadratic equation solved, we'll be in a position now to find the value of R. Now, solving this equation that we have here, we can be able to use maybe completing square method, using quadratic formula, factorization. You have all the options open for you to decide which formula to use here, and then we will find theta equals to 3 or 4 over 3. Now, using the equation R equals to 10 over 2 theta plus, okay, yeah, so we can be able to substitute theta is equals to 3, and then we are going to get our R equals to 5. Rather, R equals to 2, because 10 divided by 5 is 2. And when theta is 4 over 3, we can also substitute into this part, and we are going to get our R equivalent to 3. Right? So that's exactly what you're supposed to do in that particular question. Now we're going to question number 5, and question number 5 is testing how to solve a curve and as well as a straight line. So let's see, we are given use algebra to solve the simultaneous equations. Y minus 3x equals to 4, x squared plus y squared plus 6x minus 6y equals to 4. You must show all stages of your working. Now, at this point of time, I would like to press the first equation that I'm having here there. I'll make y the subject of the formula, right? So that I can be able to substitute it into the second part of the equation. So in that case, where I'm having y in the second equation, I can substitute or replace that with 3x plus 4. And remember, you are squaring. Ensure that you are very, very careful when you are working out the expansion, so that you don't make a mistake anywhere. Because if you make algebraic errors there, it will end up in tears. Yeah, you'll reach a point whereby the equation you have is not solvable, right? Or the equation you have is wrong, and that will cost you a lot. You're gonna lose marks and you're gonna miss some points. Now we have the quadratic equation being 5x squared plus 9x minus 2. Now, at this point of time, we can be able to solve this quadratic equation using the formula that you are comfortable with. So it's good that you write a few steps of solving that quadratic so that you can be able to put it in your calculator and then get the value of x, in this case being equivalent to 1 over 5 or x equals to -2. So you see we have two values of x, so also we are going to get two values of y. So when x is 1 over 5, we can be able to get what the value of y is in that case. Alright, so we can be able to substitute into this equation here and then try to work out things. We are going to get the value of y being equivalent to 3 over 5 plus 4, and that is going to translate to you can just put it in a calculator and try to work it out. We're going to get 23 over 5, and when x equals to -2, we can be able to substitute also and get the value of y being -2. This is -2, right? Yeah, this is -2. Yep, -2. Right, so we have the two values of x and also two values of y. I believe you've understood up to that point. You've understood what you are supposed to do. And I want us now to change the gear so that we can talk about curve sketching. Sometimes you are given question to sketch curves, and I'm going to take you through on how to go about it. So we are going to have a scenario whereby you are given an equation y equals to 1 over x plus b plus all minus c. So this is a general equation of reciprocal graphs. And in that case, what we are going to say, whenever you are sketching this kind of curves, whenever you are sketching this kind of curves, you need to know the horizontal asymptote and you need to also know a vertical asymptote. Something that I need to mention at this point is that asymptotes are lines where the curve will approach, but it will never touch that line. The curve will never touch the asymptote. It will approach it, but it will never touch it. So in this case, if you are given y equals to 1 over x plus b plus or minus c, I mean a general equation can be of the form y equals to 1 over 2x minus 5 plus 6. That plus 6 gives us the horizontal asymptote. Plus 6 gives us the horizontal asymptote. So meaning the horizontal asymptote is going to pass where y is equals to 6. So if that value was minus, we were to say the horizontal asymptote is minus 6. So that's why I said that what the horizontal asymptote is plus or minus c. That value that could be there, plus either plus or minus, that will take the asymptote, will be the value of the asymptote. The vertical asymptote is going to be given by this value that we have at this given point, this one here. This one will give us the vertical asymptote. So this is the part that you take and equate it to 0 and then make x the subject to the formula. So for you to get the vertical asymptote, you use whatever that is in the denominator, equate it to 0, make x the subject of the formula. So vertical asymptote, we have said, is going to take that. So horizontal asymptote is going to be taken by this. You take the sign that is there. And in that case, if you look at whatever equation that you are having somewhere here for this example, we say that the horizontal asymptote is going to be what? The horizontal asymptote is going to be y equals to 6. Horizontal asymptote, y equals to 6. But if we are talking about the vertical asymptote, this vertical asymptote, we are going to take 2x minus 5 is equals to 0, then make x the subject, and that's going to translate to x is equals to 5 over 2 as the vertical asymptote. Vertical asymptote, take the denominator 2x minus 5 equals to 0, make it the subject of the formula. Okay, now sketching the graph, that is exactly what you're gonna get. You have horizontal and vertical asymptotes, and then we can be able now to say the graph will look like the one that we are having on the next section. Now, another example of a reciprocal graph that you can have, for instance, if you are told to sketch y is equals to 1 over x minus 3. Now, you can see in this one, we need to identify what the asymptote is, what the asymptotes are. And the horizontal asymptote is going to be y is equals to 0. Yeah, we need to identify the asymptotes. Horizontal asymptote is going to be y is equals to 0, because you see after 1 over x plus 3, there's nothing written there. It remains is plus 0. So the horizontal asymptote is y is equals to 0, right? And then we have the vertical asymptotes. We can see the denominator is x minus 3. So we are going to say x minus 3 is equals to 0. Then we shall take 3 on the other side. So x equals to 3 is the vertical asymptote. Now, something else that you need to know for you to sketch curves, you need to know the intercepts. And in this case, we need the y-intercept. And remember the y-intercept, x is equals to 0. So we can be able to substitute x equals to 0 into the equation that was given. And then we shall get y is equals to negative 1 over 3. So this graph is going to cut the y-axis on a point negative a third. Okay. And you can see now, since we had said the horizontal asymptote is y equals to 0, which is actually the x-axis, this line has no, the x-intercept has no x-intercept. So we can now go ahead and try to sketch the graph the way the graph looks like. This is our beautiful graph. This is the horizontal asymptote. And then we have our vertical asymptote being passing through these points. Conventional asymptotes are conventionally indicated using dotted lines, so meaning the curves are going to approach those lines, but they will never cross those points. So the curve is going to cut the y-axis. For this case, the y-intercept we see is negative 1 over 3. So the graph is going to pass through that point like that, and is going to pass that way without touching those asymptotes. So that's how you are able to sketch that graph that was given, y equals to 1 over x minus 3. Let's look at the second curve that we are given here. We are given the second curve. Let's see a curve that it behaves like this. Part B, y equals to 1 over x minus 3. So this one, the horizontal asymptote is going to be y equals to negative 3, right? And this gives the horizontal asymptote. If there is nothing added or subtracted, it means that the horizontal asymptote is y equals to 0. Then the denominator here is 0 for is x, so we are going to say x is equals to 0 as the vertical asymptote. Let's check. Do we have the y-intercept? Do we have the x-intercept? We don't have the y-intercept. What we have is the x-intercept in this case. Therefore, the x-intercept y is equals to 0. Then we can be able to substitute what we have, and we get the x-intercept is going to be at x equals to 1 over 3. So it has no y-intercept because the y-axis is acting as an asymptote. So sketching this graph, we can be able to say we are going to get this. Let's identify the vertical asymptote is this one. We have the horizontal asymptote. Horizontal asymptote is y equals to negative 3. The x-intercept, it was a third. So x equals to negative 3 is the horizontal asymptote. Then right, so our graph is going to pass like that. Now it's going to go this way, graph is going to pass this way. Let me just smoothly draw it like that, and also this end here. This is how the graph is going to look like. All right. So basically, we've done a discussion on how the graphs, reciprocal graphs, are supposed to be drawn. I need us to change the gear so that we can go into the exam question and see how that question was asked. We have the curve C, which has the equation y equals to 1 over 2 minus x. So we're supposed to sketch the graph of C. On your sketch, you should show the coordinates of any point of intersection with the coordinate axis and state clearly the equation of the asymptote. We have identified, in this case, can you just comment in the description below? What should be the horizontal asymptote and what should be the vertical asymptote for question number 6? We have done some questions to show you how you need to go about this. I want you to leave a comment below. What is the vertical asymptote and what's the horizontal asymptote for question number 6? Pause the video, leave the comment so that once we start doing it, you can be able to tell exactly what you are supposed to do here. Now, let's have a note. We write a note here. In the event you have an equation like this, y equals to 1 over x, we know the vertical asymptote is going to be x is equals to 0, and the horizontal asymptote is going to be y is equals to 0, right? So we are going to have the asymptotes like that, and then the graph is going to go this way, and also the other section of the graph will go there, right? So that's how the graph looks like. Now, if you have 1 over negative x, the asymptotes are the same, but the curve will be reflected. The curve will be reflected on the y-axis. You should have your graph behaving like that. So, whenever you're going to sketch this graph that we have here, we are going to have the second part of the graph. So the horizontal or the vertical asymptote is going to be x is equals to 2, and the vertical asymptote is x equals to 2, but the horizontal asymptote is y is equals to 0. Then now we need also to know what is the y-intercept in this case. What is the y-intercept on this case? Y-intercept is when x is equals to 0. Then substituting x equals to 0 into the original equation that was given, we can be able to get y is equals to 0.5. Then let's now identify the asymptotes that we had and the point where the graph is going to cross the y-axis. This is also the horizontal asymptote, right? Then the graph is going to pass this way and also is going to pass that way. And this point here is 0.5. That's how the graph is going to behave. So you need to know the general equation of how the graphs look like, and don't forget to indicate what the y-intercept is or x-intercept is if it exists. Now we need to go to the next bit of the question, and that is part B, whereby part B we are told that the line L has the equation y equals to 4x plus k, where k is a constant, and it's given that L meets C at 2 distinct points. Already we have mentioned how to deal with when you are told 2 distinct points. When you are told 2 distinct points, it means that the discriminant is greater than 0. So in that case, we are supposed to solve the equation of the straight line and the curve. Remember, the curve was that one, and that was y is equals to 1 over 2 minus x, and the equation of the straight line is that. So we can be able to equate the two, form a quadratic equation, And from this quadratic equation that we are going to form, we are going to find the discriminant of the quadratic equation, right? So simplifying this, what is it going to become? It's going to become negative 4x squared plus 8x minus kx plus 2k minus 1 is equals to 0. So here we can be able to factor x out so that we can say our b is 8 minus k and our c is 2k minus 1 and say equals to 0. So using this quadratic equation we have obtained, we can be able to find the discriminant. And when you are told meets at two distinct points, the discriminant is greater than 0. Greater than 0. So we can be able to find the discriminant using the formula b squared minus 4ac greater than 0. And then we can form a quadratic inequality. This quadratic inequality is the one that we are going to solve so that we can be able to state the range of values for x that we are being asked down below here. Solving the inequality, we need to treat the inequality as an equal sign so that we can be able to solve the quadratic equation. We get the critical points. The critical points for this inequality is k is equals to negative 4, k is equals to negative 12. Then we can be able to say because it's greater than, so we need the upper part of the curve. So this is negative 12, this is negative 4. So we need the solution is values greater than negative 4 but less than negative 12. So ensure for you to write the final answer, don't bring another variable because the variable that we are having here is k. So make sure your answer is in terms of k. K is less than negative 12 or k is greater than negative 4. Don't use and, use or when you are stating the final answer. Otherwise, if you don't use or, you are going to get it wrong. All right, so we need to move to question number 7, and the question number 7 also is a simultaneous equation that has been asked in previous years. So we can be able to use the second part of the equation here in order to substitute into the first equation. In that way, we are going to substitute y into equation 1 so that we can form an equation in terms of x. So we are going to have a quadratic equation in terms of x so that we can be able to show that whatever we are getting is equivalent to what was given. So we can be able to divide this part that we have by 2 all through. If we divide all through by 2, all right. Yeah, simplifying that, we are going to get 2x raised to power 4 minus 15x squared minus 50 is equals to 0. And solve the simultaneous equation. And to solve this, remember this is a quadratic equation, but x in that case is x squared. So we can be able to say let x squared be m. Let x squared be m so that we can be able to write our equation that was given here in terms of m. We'll be able to write that in terms of m. But of course, once we have written it in terms of m, we are going to solve it as a quadratic equation. Once we have gotten the solution for m, we can now go back again, find the real value of x. In that case, if you solve this quadratic equation, you are going to get your m being 10 or m equals to negative 5 over 2. But negative 5 over 2 is not correct because there's no way you can be able to square a given number, you get a negative value. So we cannot take that. Then we're going to say our m is 10, then we can be able to find the square root both sides, and our value of x is going to be plus or minus 10, because whenever you find the square root of a number, you have two answers, positive or a negative value. So for us to find the value of y, we are going to substitute x into the equation that we were having there, which was y equals to x cubed minus 6x so that we can be able to get the value of y. When x equals to root 10, we're going to get the value of y being equivalent to what? Being equivalent to 4 root 10. And then when x equals to negative root 10, we are going to substitute into the equation so that we can be able to work it out, and that's going to try 4 root 10. Having this, we can go ahead and state the values and the answers that we got. We got 2 values of x and also 2 values of y. In question number 8, we are told a rectangular sports pitch has length x meters and width y meters, where x is greater than y. Given that the perimeter of the pitch is 350 meters, write down the equation linking x and y. So we know that the formula for perimeter of a square is 2 in length plus width. Then we can be able to substitute the length and width in terms of y and x. We can then divide all through by 2. That gives us a simplified expression for the equation that was expected, and this is equivalent to 175. But we know that area equals to length times width. Then working out this, we are going to have our equation xy equals to 750. That is for part B. C, we were supposed to find the values of x. Of course, we're going to solve the 2 equations simultaneously, the one in A and the one in B, so that we can be able to get the exact value of x and y. Here we're going to use substitution. Of course, anywhere we are going to have y, we're going to replace with 70 over 50x, and that is going to translate what? We can multiply all through by x so that we can form a quadratic equation which we can solve in order to get the value of y. Solving the quadratic, we're going to get the value of x as 105 or 70, which means that we can go down and work out the value of y. Y, of course, is 175 minus x. So if we just subtract that, we're going to get 70. So meaning our y is going to be 70, x is going to be 105. Remember, you were told that x has to be greater than y. So that's the condition that we are using so that we can decide that x is going to be 105 and y must be 70. We are supposed to show that 3p squared minus 10p minus 8 is greater than 0. But we are told that the equation that is given there has 2 distinct 3 roots. So where is that information coming from? It's like we were having 2 equations, 4 into p minus 2x, and it was equated to another equation which was 12 plus 15p over x plus p. So if you equate 2 equations and you try to solve them simultaneously, if they have 2 distinct roots, it means the quadratic equation that is going to be formed out of that equation that is there is going to have a discriminant greater than 0. So that is the perspective we're going to use. Now, in order to arrive at that, we are going to multiply both sides by x plus p so that we can get rid of the fraction that we were having at this given point. So we shall multiply this by x plus p here so that we can cancel out and then expand whatever we have in the left hand side, right? We shall expand that and then put the like terms together. So expanding this, we are going to have it simplified further, right? And of course, this is going to reduce to that equals to 0. So we have a quadratic equation, and I want you to look at this keenly. don't get confused. Our quadratic equation is having the variables x. The variables are x, but p is a constant. So we're going to have the value of a being -8, the value of b being -4p, and the value of c to be the entire of that bracket that we are going to have there. So that we can now say the discriminant must be greater than 0, because we were told that it has two distinct roots, right? Then, using that condition, we have said a is this, a is -8, b is -4p, and c is the entire of that is in the bracket. Now, substituting exactly what we have in this, we can be able to now solve this, put the like terms together, ensure you expand everything over the bracket that you have carefully. Don't make a mistake so that you cannot carry forward those mistakes. So we can divide all through by 48 by 48, and then we're going to end up having the equation that was given as what we were supposed to show. Hence, using algebra, find the range of possible values of. How do we do that? We are going to solve this quadratic equation that we had formed somewhere here. So solving that quadratic equation, we can be able to get the value of p as 4 and p equals to -2/3. Then, of course, it was an inequality. We are going to sketch that graph, and we need the upper part of the graph. So the upper part of graph is defined by these values, more than 4 and less than -2/3. So we can be able to write the value of p is like that. And as I've mentioned before, you must say p is greater than 4, or is a keyword when you are writing your final answer. Because if you make a mistake and say and, you're going to get it rough. Right? If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. Remember to check in the description. We have the PDF of this paper so that you can be able to download it and get to work on it as you are preparing for your exam. All the best in your coming exams. Remember to share this channel to the rest of your classmates so that they can also benefit from the same. We are going to do the last two questions, and the last questions are questions to do with linear simultaneous equations. Of course, the other one I think is having a graphic format. Okay, I'll see. See, now we are given word problems like this ones, and then you're expected to find the values of the constants. So modeling of given situations. A tree was planted in the ground. Exactly 2 years after it was planted, the height of the tree was 1.85. And exactly 7 years after it was planted, the height of the tree was 3.45 meters. Given that the height, h meters of the tree, t years after it was planted in the ground, can be modeled by the equation h equals to at plus b, where a and b are constants, then we are supposed to find the value of a and b using simultaneous equation. So we are going to form two equations here, and the first equation is going to be what? When t is 2 years, and that's going to be our first equation. The second equation will be when t is 7 years, and then subtracting the two equations, that's going to be -8/5 is equals to -5a rather, and dividing both sides by -5, we are going to get our value of a to be 0.32. Now, once we have the value of a, we can now find the value of b by substituting into the one of the equation, and our b becomes 1.2. Now we can be able to say our model equation is this. Because we want to find the height when the tree was planted, it means when the tree was planted, t was 0, time was 0. So we can be able to say that this equation is going to reduce to 1.21 meters. So when the tree was planted, it was having a height of 1.21 meters. Then finally, we have the last question. The last question is also regarding model. The company has some share price of company is monitored. Exactly after 3 years, the price was 1.05. After 5 years, the share was 1.65 pounds. All right, so we are going to find the value of P and Q. In this case, also, we are going to form two simultaneous equations using the information provided. And the first equation will be formed. The first equation will be formed when T is equivalent to 3 years. Then we can be able to substitute into the model so that we can have this as our first equation. When T is equivalent to 5 years, we are going also to substitute into the model equation and then form the second equation as such, and we call it equation number 2. Then we shall solve the two simultaneous equations, linear equations, and beautifully we are going to subtract the two equations and we shall eliminate Q, and we end up having P equals to 0.30. Then substituting into one of the equation, maybe equation 1, we can be able to find the value of Q, and in that case our value of Q translates to 0.15. For B, we are supposed to find the value of T when according to the model, when the price was 2.5. So of course, we know the values of the constants, then we can be able to know what T is. Remember, T is time. Then if we substitute the values into that, we can make T the subject of the formula, dividing by 0.3 both sides. We are going to have our value equivalent to what? Equivalent to 7.8 rather. If we work out this is going to become 7.8. Of course, we can leave it as a fraction, but if you round off, you are going approximately 7.8. Up to that point, see you in the next video. And if you are new to ProfLearn YouTube channel, consider subscribing, share this video to the rest of your friends. Don't forget to check in the description for you to download this. Watch out for the next bit of the video.